master's degree from Rwanda University of Rwanda, with specialization in health supply chain management. He's also, as I already said, the SG of our society, LMSK. Arthur currently serves as the Sub-County Medical Laboratory Coordinator for Samia Sub-County in Busia County, where he oversees the coordination, quality assurance, and strengthening of medical laboratory sciences across health facilities. His work focuses on improving diagnostic capacity, optimizing laboratory supply chain systems, and ensuring the availability of quality laboratory services to support patient care and public health programs. With a strong interest in laboratory systems management, supply chain optimization, and quality improvement, Arthur continues to contribute to advancing laboratory medicine through leadership, mentorship, and professional engagement within the laboratory community. He's the right person this evening to take us on this topic beyond the price tag, whole life costing for smarter laboratory equipment procurement in Kenya Medical Laboratory. So members, help me to welcome Arthur as he takes us through this topic this evening. Karibu sana Arthur, and I will urge members to give him his claps, his flowers, even as he takes the floor. You're welcome, Arthur.
Hello, how are you?
Fine, Arthur.
Yeah, are you able to see my screen?
Yes, I can see your screen.
It's moving. Is it moving?
Yes.
Okay. So I think because we've done the introduction, we can move forward and probably continue from where you have left. So as you've been told, my name is Arthur, and I'm always with you here, championing Matters Medical Laboratory. And so today we want to ensure that we are able to learn and also be able to equip ourselves on matters of how best we can procure the right equipment using the affordable resources that we have, but ensure that we get the longest serving and the highest quality of service from these equipment that we're able to buy. When we want to buy equipment, we must have a plan. And therefore, the plan starts from a needs assessment. We have to assess our needs. After doing the needs assessment, we have to do planning and budgeting. After you're done with planning and budgeting, then we have to move forward and procure. So once we have procured, so there's a lot that happens between the time we procure an equipment and the time we decommission an equipment. Because when you talk about decommissioning an equipment, then it means that is the last life that equipment is having. So you have to decommission it. Now, medical laboratory, as you always know, relies on automated diagnostic equipment. We normally know this. In most of our facilities, we have got equipment which are automated. I know we have some facilities which still have equipment which are semi-automated. Some equipments are manual as well. But nowadays we are improving. We are getting digitalized, and most of our equipments are actually automated. So because of that, it is important that we understand a number of things that are happening that can guide us on how best to choose on equipments and to ensure that we are able to get the best out of these equipment that we are choosing. So what we mean when we talk of whole life costing, there's a lot that we mean here. And so we want to understand when you're talking about whole life costing, this is the estimation. Let me use that word, the estimation that you put in place to ensure that all the logistic matters are within you are you are rich and you are able to ensure that the equipment that you are able to buy, you'll be able to service it, and you'll be able to maintain all the costs that come with buying that particular equipment. It does not just end with purchasing the equipment and stationing it at your workplace. There's a lot that happens that we need to understand it. I know many of us might not be understanding what happens behind the curtain, but today at least we are going to understand quite a number of things. So whole life costing considers all costs throughout the equipment lifespan. This one is installation, reagents and consumables, maintenance, servicing, utilities, financing, and also disposal, just the way I've told you. Now, by evaluating these factors, laboratories can make more informed procurement decisions, ensuring that equipment is not only affordable to buy, but also sustainable to operate. And especially, this is an important consideration in resource-limited healthcare settings, such as in most of our facilities that we are having currently. With the county government, the national government, I know we cannot afford to have all the resources that we want. And because of that, it is prudent enough if we are sure of what we are doing so that we do targeted purchase, whereby we buy the instrument that will give us the value for our money, and an equipment that will give us the best service that we want. Now, we have got 5 categories that we always look at when we are doing whole life costing for an equipment. So we have 5 categories. There are a number of them subcategories, but then the main 5 categories are these ones that we have. The first one is the acquisition cost. And this is the cost that includes the purchase price, the cost for delivery, that is transportation, the cost for installation, when the biomedical engineer comes to the facility to install this particular machine, that is the cost involved. We also have a training cost. We also have the initial support, because once you come in to train, then you must support the staff that are going to be subjected to this particular training with maybe a number of materials that are needed in the process of the training. And then after the training, you have to assess the knowledge that has been gained. So in all these processes, then we must have a budget for this process. Otherwise, if we only have the budget for purchasing the item or the equipment, and we don't have the budget for delivering the equipment, installation, training, and any other support that comes with this accusation, then we will realize that we will be stuck. And equipment will come to the facility, but will not be able to operate that facility. That equipment, sorry, will not be able to operate that equipment because we have not been trained. So training must be part of acquisition. And in the process of training, then it means you have to factor in the biomedical engineer who is coming to install this particular machine. Then we also have the second category, that is the ownership cost. So when you talk about ownership cost, we have a lot that we're talking of here. One, we have the cover insurance. As you know, most of the laboratory equipments are very expensive. So if we don't insure them, then it means in cases of maybe damage, maybe fire, or maybe electrical damage, or maybe theft, then it is a big loss, because we cannot have. So if we insure such a machine, then it becomes easier for the insurance companies to do what? To at least do a replacement. Now, this insurance comes with a price. We cannot just insure it without money. So money must be costed here. And so that is where we talk of ownership cost. So insurance cover is one of the ownership costs that we have to take care of too. There is regulatory compliance. For example, you want to bring in a biochemistry machine to your facility. And remember, your facility is a certain class. It's maybe class B, or a class that is not authorized to operate a biochemistry machine as per the KMLTTD Act. Now what happens? Then you have to comply by upgrading your laboratory. So that one is compliance cost. So when you're talking about compliance cost, this one must be paid to our regulatory body, that is the KMLCTB. And so it is a cost that you have to factor in if you are talking in terms of such kind of equipment, for example, an equipment that needs a higher class of laboratory. And so another area of interest in terms of ownership cost is financing. When you're talking about financing, then you remember most of these equipments are expensive and many facilities cannot buy them cash. And so if we cannot afford to buy them on cash basis, then we opt to do financing. Maybe we opt to do loans. So if you're opting to do the loans, then the loans comes with the interest. So when we're talking about interest, then we must post this interest that we'll be able to pay back. So apart from just the purchase price, then this interest that you've taken in terms of loan, it comes with an interest. This loan that you've taken comes with an interest. So you have to factor in that interest. That is why we bring in financing here. And then remember depreciation. As the machine depreciates over time, for instance, 5 years, a period of 5 years, then even the functionality, the performance will go down. If the performance goes down, then it means maintenance will go up. And so you must have a plan on how you're going to factor in the depreciation to ensure that it can still work optimally before you decommission it. So all these costs we group them under ownership. Then we have operation costs. These are the day-to-day operation that we have. This involve the reagents and the consumables, electricity, water system, and the personnel as well, because most of these machines cannot work without personnel. So it means there must be personnel, and they must have the right training in order to operate these machines. And then we have the fourth cost, which is the maintenance cost. So here we have the first service contract. So when you are costing, then you must have a plan. How many times are you desiring, or which type of machine are you desiring to purchase, and what is the service contract? How many times should that machine, as per its manual, it should be serviced, normal servicing? What about breakage? How many times should services be rendered if in cases of breakage? And the normal service per year. So you have to factor in that. So that is under maintenance. So we also have spare parts. We also have calibration. We also have downtime cost. You also must have a plan on what happens, or what alternatives will you have in case of downtime, in case your machine has broken down and so the services must proceed. What particular um, alternative in terms of machine will you be able to bring on board? And so all these are factors that you have to ensure that you are able to consider. And so we also have decommissioning, that is disposal. We must have a plan on how to remove this machine from the facility. We have to consider, when we're talking about this disposal, I know you understand IPC. So when you talk about IPC and laboratory equipment, then so you must have a plan for that. And also remember, when you're talking about disposal, when you are decommissioning, or you are removing that machine from the lab, you can decide to sell it to another facility that can operate it. So the resale value consider when you are in terms of the cost. So let's look. So we've just discussed about the cost that we the 5 categories. So our first category, the way we've discussed is now before I probably talk about the acquisition cost. Allow me to say something about decommissioning. When we're talking about commissioning, this is the process of safely removing a machine from active service when it reaches uh, uh, the end of its useful life or is no longer needed. Now it involves shutting down the equipment, disconnecting it from power and laboratory systems, removing it from the facility and disposing it. So you can decide to recycle or you can decide to sell it according to safety and environmental regulations. So if we're giving an example on this, we can say, for example, a 10-year-old hematology analyzer with a newer model. So if we're replacing an old hemolyzer with a newer model, now the old, the biomed will shut it down, the systems, and then the reagents will be removed. Uh, hazardous material from particular equipment will also be removed. It will be disconnected from electrical and water connections because remember, we have got machines or equipment that are connected to our water supply. For example, the autoclave, for example, you realize that some big ones are connected to water sources. So when you are decommissioning that, you have to do the electrical connection, disconnection, the water source disconnection, and you must also ensure that patient data is also cleared from the system. Remember, most of these machines have got data storage systems. So you must make sure that patient data is cleared from these machines, putting in mind the Data Protection Act. And so with all this, then you need a professional who will be able to do this particular job. And so you must plan for the costs that comes with that particular role. So let us go back to our um, this area of interest, that is the acquisition cost. And so we want to look at a simple example. So generally, when a laboratory is probably buying a hemolyzer for example, at 8 million. So this 8 million will include the machine and the standard accessories. However, this is not the final cost for this particular machine. Remember, there are other costs that will come. For example, if it is bought in Germany or India or the US or maybe any other East African country, so there's importation. You'll import it, you'll bring it into the country. There's shipping, there's custom clearance at the port. So these are some of the logistics that are not included in the initial particular biomed engineers installs and validates this system. They have to install it and validate it. And so this one also comes with another price. So staff training, and so you end up spending probably another million on top of the 8 million that you had bought the equipment with. So you'll be running at around 9 million plus. And so generally that is that. So it's important that you take care of that particular area. So so we have got the delivery and the logistics, the installation, the training. So you see, like the way it is displayed, we have got supplier A and supplier B. So supplier A purchases that equipment at 11 million, and supplier B purchases the same equipment for that matter. But now the differences comes in installation. For example, supplier A will install that equipment at 300,000, while supplier B will install the same equipment at 50,000. When it comes to A will train for free. When it comes to support, supplier A will support for free. I hope we are able to get that well. Now, but now when it comes to supplier B, installation, they will charge 250, training, they will charge 200, support, they will charge 150. So in as much as the purchase price for these equipment at with supplier A is higher than supplier B, but there are some logistics that are taken care of by the supplier A, and they are not supplier B. So these are issues to be aware of. Otherwise, you will rush to buy from probably that that is far much cheaper, but you'll realize that the difference is not big. So that's generally what we refer to when you're talking about acquisition cost. And then when we're talking about ownership cost, so we want to probably we can break it down a little bit, and we're looking at the starting with the loan interest. Now, the loan is an extra money or an hospital or a clinic pays. Generally, when we borrow funds, we understand loans, how they work. And so if this equipment has been bought at a loan of maybe 2 million, and so there must be an interest that will be included in order to ensure that the costing is appropriate and ideal. So generally, that is what we look at. So when we are comparing suppliers, the loan interest can make a big difference. For instance, supplier A charges 350,000 on interest over a period of 5 years, while supplier B charges 520,000 interest over a period of what? For 5 years. So you'll realize that the insurance, the compliance costs are the same on both sides. But now the difference comes with the what? With financing. And so that is what we are referring to when you talk about ownership cost. Then we have to ensure that these are areas that we take care of. Now, so if you add this interest, for example, you add the equipment price plus the total paid, the total interest paid over a period of the 5 years, when you're repaying this particular loan, you'll realize that, for example, supplier A will pay 2.9. And supplier A will pay 2.8, and supplier B will pay approximately 2.9. So there will be a difference. So that is what we about ownership cost. Generally, we must make sure that we understand it well. So some of the key takeaways when it comes to loan is that the loan will increase the total ownership cost if we go for the loan facilities. And so we must factor in that. So when we're talking about these ownership costs, then the financial obligation of keeping this equipment operational over its lifespan. So this is what we refer to as the ownership cost. We must make sure that the annual insurance is paid, the compliance cost is paid, and so that is where our board comes in, and it's part of as the regulator generally. So there's not much to maybe understand about the ownership cost. It's just that simple. So we can look at our of interest, and that is the operating cost. And so under operational cost, now let's look at these operational costs. Now, these are the daily expenses that we incur in running a laboratory analyzer over its lifetime. Typically, we're talking about probably 5 years. That is the optimum number of years that a machine will run optimally. So when we're referring to 5 years period, we realize that this cost will include the test kits, the equipment with the reagents is now. So for the operational cost, we have also electricity for operating that particular machine. We also have the cooling systems, for example, the air conditioners that we install in our laboratory. They're also part of operational cost because they will also consume electricity in order to uh, uh, produce the right environment for this machine to work optimally. So consumables like pipettes and the tips, the labor for the trained staff, these are some of the examples that we incur when we are talking about operational costs. So this cost must be included when you're talking about whole life costing. For example, suppose a lab operates a biochemistry analyzer. So the annual cost for reagents and test kits might be around 800,000. Electricity could cost 180,000, and probably consumables such as pipettes, cuvettes, tips may add to around 50,000 per year. Now, labor for the trained staff to operate the analyzer might probably be 120 annually. So over 5 years period, the operating cost might add up to be a huge sum of money that can go up to maybe 20 million shillings. So if you don't factor in this particular cost, then you'll realize that you will be eating into your profit unknowingly when you are running your facility. Because you'll realize that the operation cost for running that particular machine is very high because you never factored it in before purchase. But if you do the factoring in before purchase, then you'll be able to tell if that machine is worth buying or not. Now, we can compare as well two suppliers, the way we discussed supplier A and supplier B for that matter. Now, you realize that supplier A might have a slightly lower annual operating cost, while supplier B consumables and maintenance requirements could be higher. So those dynamics are what will decide, what will dictate which machine are you picking from which supplier on in relation to operation cost. So these examples will show you how operation costs are just important as the purchase price when selecting equipment. Even if the analyzer is cheaper upfront, higher running costs can make it more expensive in the long term. Understanding these in terms of purchase will help you in the budgeting plan to accurately ensure a sustainable and efficient use of equipment once you purchase that particular equipment, because you'll have an idea of what is needed. So when you're talking about operation costs, remember reagents, remember electricity, power generally, remember labor, and also remember consumables. So we can look at this other area of interest. We call it maintenance cost analysis. So when we're talking about maintenance, generally that was operational cost, but now this is maintenance cost. So there's a difference. So when you talk about maintenance cost, so this is the cost that comes not with the day-to-day running of the machine, but this is the cost that comes when you want to keep on routinely checking on the performance of the machine and ensuring that preventive maintenance is taken care of to ensure that there's no time the machine breaks and to reduce the downtime. So, or what do we look at generally? So as you can see from the projection that you have, uh, generally you can realize that preventive maintenance, these are regular servicing. So system checks to prevent what? Failure. So when you talk about maintenance costs, so we also bring in the spare parts. So you must factor in some of the spare parts for the machine. So some suppliers will tell you that they will be supplying the spare parts for you for that particular period for free. Or maybe they'll give you a warranty for 2 years or 3 years. And in that warranty will entail servicing, it will entail spare parts, and it will entail what? Calibration. So some of these details you have to consider. For example, if you get a supplier who is able to give you spare parts, is able to do preventive maintenance, and is able to do calibration for free, apart from maybe the basic buying price of that particular machine. So you realize that those are charges that you will leverage on if you take that offer. But some suppliers will not tell you that. They will simply sell for you the machine, and you will have to factor in this maintenance cost by yourself. So if you are not aware, you will only come to realize this once the machine has broken down, and now you're calling the supplier, and the supplier will tell you that we never agreed on how to service the machine in terms of the logistics. So you'll be forced to uh, um, foot these bills. Remember, some of these bills are very expensive. Some machines, the company or the supplier will tell you that to serve this machine, we need to bring an engineer from South Africa. Because remember, some machines have got their headquarters or where they're manufactured are not in Kenya. So they'll tell you that we for this machine for us to come and for us to come and repair your machine or do maintenance service, then you have to airlift our biomed from the US or from Germany to Kenya to come and what? To come and service that machine. And that the logistics will be on the what? On the owner of the machine. So if you never factored in this cost, then you'll end up spending more. So you need to ensure that these costs are taken care of. So, for example, suppose a lab has a biochemistry analyzer. Over 5 years, the preventive maintenance cost includes spare parts costing, for example, 750. Then there's also calibration and accuracy verification. So you will end up spending more money on these issues if on these areas if you didn't plan for them. So you need to have a plan on those particular areas. And then, for example, want to give an example with this particular calibration. And so we have got two types of calibration. One, we have the manual calibration, and we also have the automatic calibration. For example, if you look at this machine, this is Mindray BC 5000. Now, this machine can auto-calibrate itself as per the manufacturer's description, that is the technical specifications. Now, if it is able to calibrate itself, it means you will the analyzer it has got the internal and the automatic calibration system. So this one usually happens at intervals. It's if you're able to schedule it to perform the running of batch of after a given batch of samples, then it calibrates itself. Now, this one, remember, it requires minimal staff intervention, and it also reduces human error. Now, the cost implication, now, while the prices will be increased for this matter, the purchase price will be increased for this matter, or the service contract fee due to the advanced software that it has, plus the sensors. Now it reduces the labor cost and the downtime and the risk of inaccurate results. So, for example, a fully automated biochemistry analyzer may cost 500,000 to 1 million or more upfront, but over 5 years, it can save a significant amount of of money and resources, uh, because of this auto calibration. Because you will not need maybe the biomed engineers to maybe come and maybe do a number of AJTs, do a number of calibrations, leave you read the report. The machine is able to do it on its own, unlike a manual calibration system. So if you are doing maybe considering an equipment, then this is another area that you can consider. So you have to cost. So when you're buying an automatic machine that is able to auto-calibrate, then you are sure at long run, the cost of maintaining that machine or doing preventive maintenance will be low. And hence the whole life costing will also be ideal for this particular machine. And so we also have another area of interest, and that is the disposal. And that is the disposal and what? The disposal and the resale value. So these are just practical. For example, just the way we've discussed it in our earlier slide, you can see those are some of the components that we put into place. The procedure for decommissioning, so that at least we can create space in the lab, and also the compliance in terms of disposal. And also if we are reselling it, or maybe we are trading it in with another machine in order to recover value, then these are areas that we have to work on and ensure that we get value for money. So you can see we have got two machines there from two suppliers. And so there are so many, there's a difference. There's a difference in terms of the disposal. So you can see in machine A, the removal cost plus the disposal cost, it's into the resale value, and so it drops to 1.1. And so you look at this other machine, that is supplier B. For example, now the removal is 250 and the disposal is 150. Now it's into the resale value for that particular machine. So if you are reselling that machine at 900,000, so you've taken care of the removal and the disposal costs. So that machine, its resale value drops to 500. So when you're talking about resale value, when you are disposing the machine or decommissioning the machine, then you must also factor in the cost that will come with the removal of the machine and the disposal, and all the procedures that will have to be followed when you are generally disposing the machine. I don't know if you're able to hear me, Madam Nelly.
Yes, I can hear you, Arthur. You are loud and clear.
Okay. Thank you. So generally, so just the way we said, some equipment can also have a resale or trading value, which can offset part of the cost. However, there are hidden costs to watch for, such as transportation fee, disposal of the hazardous components, or staff time for decommissioning. So when you are doing all this, then it means you have to designate a staff or redeploy a staff to do all this work, or you'll outsource a staff from elsewhere to come and do all this work, and that one comes with a cost. Now, remember, just the way I've explained, decommissioning is not free. It includes engineering time, the hazardous disposal, transport, and probably staff involvement. So there's a lot that comes in. And another thing that is hidden when we're doing decommissioning is the downtime and the staff diversion. Because when you're decommissioning an equipment, it means our staff is going to be diverted to that particular event or activity. And so his or her productivity in the routine work will be limited. In addition, downtime. If we don't have a plan for another equipment during this transition period, or when we are decommissioning this equipment, then it means we will not be able to run a number of tests. So this one comes with the costs. So we'll be forced to maybe get an alternative as maybe a temporary remedy as we work on maybe getting another machine, and this one comes with cost. So generally, you realize that so at the end of maybe a 5-year period, same equipment, different suppliers, you can realize that maybe one supplier will facility will have spent 42.6 million, and another facility will have spent 50.2 million. Now, there's a difference here. If you had that particular knowledge on this particular costing areas to or factors to consider, then it will be easier to have a plan and factor in all these areas before you decide on which equipment to pick from which particular supplier. So when we're talking about benefits of maybe doing the whole life's costing, then it gives us some benefits. When we implement it well, it gives us some benefit that comes with it. So the benefits and the practical implementation of the whole life costing in Kenyan laboratories, generally, it helps to facilitate. It helps facilities to look beyond the purchase price and focus on the total cost of ownership over the equipment's entire lifespan. Now, by considering acquisition, operation, maintenance, and disposal cost, now laboratories can select equipment that deliver the best long-term value rather than just the lowest upfront cost. For example, suppose a county hospital is choosing between a biochemistry analyzer A and B. So you'll realize that analyzer B has you'll realize that analyzer A may be cheaper to buy, but it requires more expensive reagents, higher electricity consumption, and frequent what? Maintenance. It is cheap, but it requires high electricity, and it requires frequent what? Maintenance. While analyzer B might be higher at the purchase price, but lower operational and maintenance cost. So when you are using the whole life costing, then you realize the hospital may find that analyzer B is actually more cost effective over a period of what? Of 5 years. So this one will save money while maintaining reliable what? Diagnostics. Now, remember that whole life costing also supports financial planning. Now, by improving budget forecast for county hospitals, for example, or public health facilities, now it can help reduce unexpected expenses, such as sudden breakdown or expensive repairs. Now, this one lowering financial risks. Now, additionally, it allows procurement decisions to be evidence-based Now, using data rather than assumption, and this promotes operational efficiency by ensuring laboratories run smoothly over the equipment lifespan. Now, of course, all life costing cannot come without limitations. It has limitations as well, but then the benefits outweigh the limitations. When you talk about limitations, we are referring to it's costly to maybe to get to collect accurate data for this analysis. Now it can be challenging for some estimates, by the way. Now, for example, reagents and maybe technologies can change with time. Prices for buying reagents can always change. So when we estimate or when you do the costing in 2026, probably the same costing in terms of reagent prices shall have changed maybe in 2028. So these are some of the areas that you have to to consider when you're doing the whole life costing. So financial efficiency without compromising diagnostic quality is important in this particular area. That one, it ensures that every investment in medical equipment delivers sustainable value. So those are some of the areas that you have to check. So when we're talking about the benefits, we're talking about long-term value, financial planning, risk reduction, evidence-based decision, and we're also talking about operational efficiency. So those are some of the areas that are important when we are referring to WLC. So and so when you can compare these three analyzers, for example, as you can see there, we have got these three clinical chemistry analyzers. One does 200 tests per hour, the other one does 300 tests per hour, the other one does 400 tests per hour. So the costing will be dictated with what you want in terms of number of tests. Now, and the level of your laboratory, for example. So you will realize that equipment A has lower initial investment, but it cannot maybe favor a bigger facility. So equipment B is more reliable with premium support. So you realize that equipment B does more tests, but then it also comes with additional what? Support. So it's appropriate for maybe county hospitals. And then we have got to equipment C, which is also that comes with the best performance, but then it cannot work in small facilities because of the operation cost that maybe probably comes with it. So what do? We can have it at the referral facilities. That is the referral hospital, the big hospital that we have in the country. So you look at the just an example of the purchase price for an equipment A, equipment B, and equipment C, and you also look at the acquisition cost that comes with them. So you realize that because of the different capacity of the equipments, they come with different acquisition costs. And so this is an example also of two hematology analyzers. You can see the technical specification that you're having. And for example, on H560, in this hemolyzer, there's something important to understand about it. There's some hidden cost that comes with it. For example, the temperature range. You told that the temperature range is about 15 to 30 degrees Celsius, and the atmospheric pressure, as you can see from this, the TS is around 70 to 106 kPa. Now, it relies on sensitive components like the laser flow and the cytometry sensors. Now, these electrical impedance circuits and the cyanide-free colorimetry system that runs it. So you realize that it cannot work under unstable high temperatures or high temperature generally. So any unstable environment affects its accuracy in terms of the WBCs, the RBCs, the platelets, and maybe the HB measurements. So it also causes these reagents to degrade and even shorten the what? The lifespan on the electronic components of this machine. So what do we do? In this case, then we must factor in an air conditioner. So that one is an hidden cost that comes in when probably you're deciding to buy such a machine because of maybe the sophistication that it has. It comes with additional what? Costs here. So, and also you must factor in now the AC in most of the hot climate areas in Kenya, in order for that machine to function what? Well. So in that part, you realize that there's additional costing that comes in. For example, the AC will consume money when you're buying it, when you're installing it, and also electrical consumption will also increase because of the AC equipment that you put there. If you don't put that, then you will not be able to protect that particular equipment because that AC will help to reduce reagent wastage. It will minimize calibration errors. It will also avoid expensive repairs or replacement. This one makes it necessary cost for long-term operational efficiency. So that is far much important. And then when you look at this other hemolyzer machine, that is the BF6900, there's something also unique about it that probably you need to understand. Now, this machine reports 27 routine parameters like the WBCs, the RBCs, the hemoglobin, platelets, plus other many parameters that it has. Now, it uses the laser flow cytometry, impedance, and immunoturbidimetric CRP testing for accurate results. That is how it works. Now, remember that is also also has that capacity of processing 60 samples, 60 samples per hour, and it supports manual or automated sampling. So this one with an optional outload as well. Now this one, remember, it reduces labor, but slightly increases the purchase and maintenance cost because it has the automatic sampling. It can do sampling. It can analyze so many samples per hour, that is 60, and it can do outloading of the samples. So this one, it reduces labor. Then it might be expensive at the purchase price and probably maintenance cost. So it also holds around 200,000 results. So it means it gives you a good database for archiving or temporarily holding results. So if you want to maybe refer to some results that were done probably last year, you can still get them from this particular machine. But then also remember that it can connect to the lab system via the USB and maybe the Wi-Fi, and so it improves the workflow efficiency. So that interoperability that comes with this machine can help you to communicate with the different printers, different other machines that you have in the laboratory. So that operational cost comes from the reagent, electricity, calibration, preventive maintenance, while that physical size and weight will affect the installation, transportation, and the eventual decommissioning cost. But then you can understand the how it can perform best. It delivers high throughput and reliable results. That is true. But its technical features directly influences the long-term operational and ownership cost, which must be considered in budgeting and procurement decision. So those are, in as much as it has a good performance, but there are areas that it has to we have to consider when we are maybe purchasing it. So as you can see, we probably have got three biochemistry analyzers. And So one needs standard preventive servicing, and you can see the price there. The second equipment needs a comprehensive support package. Maybe the supplier is able to give comprehensive support package when it comes to servicing and maintenance. And then the equipment C, the supplier is able to give premium packages. So it means when you look at equipment C, it means this equipment will never break down, because anytime there is need there is need for maintenance, then you are assured the environments will come and do it promptly. Unlike in the first case that they only have the standard preventive services, that's the servicing that you have to maybe call the biomed, he has to maybe schedule a day, maybe travel and come. So when you look at the downtime for these three equipment in terms of cost, at a period of around 5 years, you will realize that equipment A has got a higher downtime, while equipment C has got the lowest, because it is always running, because it has the premium service uh, package in terms of maintenance and servicing. So those are some of the areas that you look at. Are you planning to how to cost just the standard preventive servicing, or you costing the comprehensive support package, or you costing that is the highest, the premium? It's the most it's higher in terms of purchase, but then it gives you it's more reliable in terms of ensuring that the machine is serviced and the machine is running 24/7. Yes. So those are some of the hidden costs that you will realize. For example, in equipment A, just the way you've seen, um, it has because it has because it is associated with the low operation and maintenance expenses, it can reduce the hidden costs. So other than those other machines that you've seen, the equipment B and equipment C. So under the hidden cost, this is where we have got maybe the energy consumption. Some machines will use higher energy in terms of electricity. Some machines will need the ionized water. Some machines will need distilled water. So as part of your costing, you must cost a water distiller. You must ensure that you have a water distiller, and that water distiller will come with what? With additional cost. So you need an AC for that matter. So those are costs that you'll have to put in place. We have got spare parts and calibration, the way we discussed. Some machines will need software upgrade. So these machines will maybe you'll use them maybe for 2 years, and then you need to upgrade the software for these particular machines. And so in upgrading these machines, they come with the cost. These ones will come with the cost. So we also have some costs for hidden operational expenses in relation to this health supply. That is the supplies that will work, that you use when you are running your machines. So we must factor in some of these costs or costs. So, for example, something that maybe will increase the cost of the operational cost is when you have controls which are expiring soon, and maybe they expire before you are able to utilize them. And remember, you bought them with money, you spent on them. So generally, in that case, you will be running into losses. Then when you don't do accurate forecasting in terms of your consumption, when you don't integrate cost analysis when you are doing procurement, when you don't do proper inventory on what you have and what you don't have, then some of these hidden operational costs come in. When you don't have a planning, a buffer stock, For example, you are having you brought in reagents to last you 1 month, but then you didn't have a plan for the buffer stock. You've had a higher demand for the test. The test has gone for 2 weeks. You have run out of reagents, so you have to make fresh orders. In the process of making fresh orders, because you're making fresh orders in the middle of maybe another order, then you have to spend a lot, because remember, the economies of scale comes in here. So now, so some of these hidden costs need to be included. And also, lastly, if you don't vet or if you don't select your suppliers well, and then you will realize that there's a number of hidden operational costs that will come with the purchase that you are doing. So it is important that you ensure that you are able to vet and select your customers well, to ensure that all the details that you want in terms of whole life costing is taken care of. So these are some of the issues areas that we've talked about. We have the reagent consumption, the calibration material, the maintenance and servicing contract, the spare parts, the quality control materials, the potential downtime cost that comes in. So those are some of the factors that will decide your costing. And then some of the strategies guidelines that we need is we need to assess the volume of our labs. For example, a small lab, you'll go for a small machine like Mindre. A medium lab, you'll go for a machine like Roche. A high volume lab, you'll go for a machine like Abbott. You also need to evaluate your support network, so that you consider the technical support availability, reagent supply chain reliable, and spare part accessibility. There are some equipment that once the starter pack reagents or kits are depleted, then you are told that we don't have those you don't have those consumables in the country, so you have to import. So those are some of the areas that you have to factor in before buying a machine or buying an equipment. Some biomeds will tell you that they are in the US, so you have to pay for them their flight, you pay their accommodation before they come into the country to probably service your equipment. So those are some of the areas that you have to consider. You also need to analyze the budget constraint, factor in initial purchase price versus the long-term operational cost and the total life cycle value. And then four, you also need to calculate cost per test. So these are some of the areas that you need, like with the way we've discussed. For small labs, you need an optimal balance of capacity and affordability. For county hospital laboratories, you need high throughput with balanced cost structure. You also need for the national referrals, you need premium reliability and brand support. So those are some of the areas that you need. And so this is our parting short as we end this presentation. And so we say you invest wisely, you plan for the full life cycle, and let every Kenyan laboratory dollar deliver maximum value, efficiency, and reliable patient care. Thank you.
Thank you, Arthur, for the elaborate and well presented work. Thank you so much for such an engaging and a well-researched work. Thank you. Members, I had informed you that if you had any question or any contribution, you can just put them up on the chat. I have some that I will be going through so that our presenter can react to them. And also, if you want to talk, if you want to express it by talking, you can raise your hand. I will allow you to talk and ask your question or give your contribution. Thank you so much, Arthur. I would want to go to the chat section so that we can get to read what's there so that you can react back to members. So thank you, members. I can see. Our first question, Arthur, comes from Benson Luseneka. Benson Luseneka says, Doc, talk about closed and open machines, advantages and disadvantages of the two options. So Arthur, back to you.
And when we're talking about closed and open machines, mostly we're referring to safety issues and quality issues. In the closed machine, I know you, when we talk about closed, you understand what we refer to. Closed is where the machine is able to aspirate the both the reagent and the sample are inbuilt, while in the open, this is where you manually position the sample, and the machine is able to aspirate. So close, it's fully automated for this matter, while this other one is while open is semi-automated. So that is what we can refer to when we're talking about closed system or open system in terms of equipments for that matter. I hope our member has been answered. I hope our member has been answered.
Thank you, Arthur. Benson, I hope you are at a good place now. In case of anything, just the chat is still open. You can raise your questions. So some more reactions. We have Taj Habib that says chemistry analyzers need pure deionized water. Make sure you store in virgin translucent plastic drums. The TDS must be 000. That is Habib. Arthur, before you react to that, maybe I want to read everything that Habib has written. And he also says, there is no more distilled water. Nobody can afford the electricity bill and the large volumes of cooling water. A TDS meter is available online at 900 shillings. That's what Taj says. Arthur, maybe you can react to that.
Yeah, for the yeah, it's true. Currently, some of the so we have got this Taj is referring to the total dissolved solids. Now the TDS meter, it's true. Yeah, they're available, and so they help to dissolve the solids like the minerals, the salts, the metals, the ions, and some organic matter. So these ones will at least ensure that that water is ideal for running our machines. So it will not be able to corrode the different parts of our equipment. And so on the other issue, on the other comment that Taj has made, yeah, it's true. Nowadays, most facilities don't have these equipments because they are expensive. But I think I don't know if Taj is able to maybe unmute and comment, make that comment to all of us so that we can all of us hear it on what most of the facilities are using currently in terms of the water that they're using. Taj, are you able to unmute and probably say something?
Taj, let me try and find him. I will get him. In the meantime, maybe we can continue as I get a hold of him. More comments here. Abel Nduki says, very comprehensive presentation, Dr. Riata. Taj again with a comment during the servicing. He says, during the servicing, and installation, stay with the bioengineers to learn how the machine operates. Arthur, I would also want you to comment on that. Yes, maybe Arthur, you can take up that as I look for Taj.
Yeah. You come up again. The last question.
Yeah, Taj just gave a comment, and I would want you to react on that. He says, during the servicing and installation, stay with the bioengineers to learn how the machine operates.
Yeah, true. Yeah. Of course, that is it's a good practice. You need to because when the biomedical engineers come to install the machine, you are the staff who will be running that machine. So you need to be there so that you are able to see how the machine is installed, how the machine is how calibration is done, and probably how a number of tests are run. So that is important. I can see Dr. Gatua has raised his hand. Doctor, are you able to unmute and maybe make a comment?
Okay, Dr. Gatua, you can unmute.
Yeah, sure. Good afternoon, everyone. I hope you can hear me well.
Good afternoon.
Thank you.
Yes,
Thank you, Dr. Emery. You have done it very well. I think that's an area that very few people are talking about when it comes to equipment management in the laboratory. It's a big challenge for everybody, for most people in the laboratory, because sometimes we don't have that particular opportunity most of the time to be involved in the purchasing of laboratory equipment. But of course, in this era and time, of course, most of us are now getting to the point that we must be consulted anytime they also want to buy equipment. The user, with the laboratory personnel, must always be consulted to come up with the specs and also to guide on procurement. And to start off, I wanted to make some comments on there was somebody who asked the question between what is the difference between the closed system and an open system, Emery. And I thought I should elaborate in a better way. When we talk of closed system is the situation whereby you cannot use any other reagent apart from the one prescribed by the manufacturer or by the company that produce that equipment. So it is closed because you cannot use any other reagent from any other company. So for the open system, which of course is dying out these days, it means that you can just buy, for example, if you are doing urea, you can just buy some funny chemicals from wherever, and then you come and mix, and then you can be able to produce urea. But I must say that the closed system is dying out naturally in the field of the laboratory. These days we have only the closed system. Most of the time, 90% of the reagent we use is a closed system. Remember, these days you get reagents that are barcoded. And when you come, you have to scan so that the machine can recognize that particular reagent. So in fact, very few, if any, laboratories using a closed system. It's no longer there. And of course, it has so many disadvantages because the moment you start using open system, sometimes you not be able to even to maintain the equipment well. The engineers may not be available to give the service for that equipment. So the closed system is dying out. Is the one that is in the market these days. The open system is dying out systematically. When you talk of the various brands like Abbott, like Roche, like Mindray, like any other equipment you mention of, they come with their own reagent, and you cannot use any other reagent. So that is the closed system, and it's working very well. As we are using the closed system, it works very well. The other issue I wanted to mention about is the acquisition of your laboratory equipment. I know you have given a lot of data concerning direct purchase and probably placement. But if you are to ask me, the trend these days is to go for placement, whereby you lease an equipment for like 3 to 5 years. We call it lease or placement, whereby the hospital does not buy the equipment. What they do is that the vendor will give you the equipment, and then you buy the consumable, of course, at negotiated prices. So this makes sure that the company will come and install the equipment free of charge. They will be maintaining the equipment free of charge. And of course, technical support is there for the period that equipment will be under contract. So you realize, like when you place an equipment, there's no cost for servicing, there's no cost for technical support, and there's no cost for spare parts. So your work is only to do the test and to buy the reagent from the vendor who supplied that equipment for a period of 5 years. So most of the time is to work out very well. But of course, again, I know the vendors also look at your volume, because again, nobody wants to place an equipment in your laboratory if you are doing only 10 tests per day, because how long will it take for him to recoup the cost of the equipment? So sometimes they look at the number of tests that you do in a day, in a year, so that they can be able to do their mathematics and find out how much they get at the end of the contract period. So I think that is the best way to go for now. So if you are a manager somewhere in a laboratory, please make sure that you explore the option of a placement. It is the best practice. These days, you don't have to buy an equipment because there'll be a baggage on you. Because the moment you buy that equipment, it's your property. You have to ensure that you get a service contract. You'll be buying spare parts. There are so many overheads that you have to incur, which you can avoid if you place that equipment. You talked about the software upgrade. If this equipment belongs to the vendor, he'll be doing that software upgrade when and if it is required. So it should not be your bother to buy a software upgrade. It's already there, done for you. They will do the PPM. They will do some training, because these days also we ensure that once you get an equipment, it's on placement, a 5-year contract. You also make it mandatory that at least you take 2 or 3 people to the factory, to the manufacturer, wherever the equipment came from. So that is a way of now training you and capacity building your staff accordingly, which is also building a rapport between the vendor and your laboratory. I think that is very important. The other thing is about the biomedical. Remember, the equipment we are using these days are very modern, and they are very, very complicated. So even not every other biomedical engineer will be able to service that equipment or to do PPM. The only person who will be able to do is from the vendor, because now the vendor, they are taken to the factory for several months, and they interact with the equipment and they learn very well. So when you buy an equipment and you want to call every Tom and Dick as a biomedical engineer to come and service that equipment, they will end up destroying that equipment. And that's why sometimes you find in laboratory, you find so many equipment that have been broken down, because there's nobody to repair them. But if that equipment was on placement, you don't have to call your local biomedical engineer. You just contact the vendor, the local vendor. They have their own engineers. They come and service, and they come and do the PPM. If it is troubleshooting, they'll do it. So I think that is the best option for the laboratory these days. Thank you for those few and many comments. Back to you, moderator.
Thank you, Dr. Gatua. Thank you for your input. We really appreciate. I would like Taj. Taj, you've raised your hand. You can unmute. Taj, you can now unmute so that you give us your contribution.
Okay, I don't know whether you can hear me.
We can hear you. Thank you.
Okay. Okay, thank you. I was pressing the wrong button. Okay, I am agreeing with the speaker just now that the closed system is good, but lately we have had a problem in our lab. The vendor of the equipment and the reagents didn't have a particular uh, kit we wanted very urgently to do microalbumin. Now, how do you sort that problem out? You can't use another kit, and the vendor doesn't have it. So that is an issue with closed system. Personally, I'm very much for the open system, but nobody today will give you an open system analyzer. They will all close it. But there is a problem with the closed system at times. Okay, that's having said that. Now, when it comes to equipment, one thing we have learned in our facility is that our enemy number one for our analyzers is dust. Because every time he opens the Sysmex or the Cobas, it's packed with dust. So I tried to talk to Sysmex people, and they told me, yes, there is a solution. So if you are installing a machine in anywhere in Kenya, you will get dust. So there is a filter you can buy from your supplier, which is fitted outside at the vent. So this is it's not a cloth filter. It is something you use. Maybe the ladies will know, if you have a cooker uh, at home, there is a kind of a filter which is in your the one for filtering oil. It is like that. So whenever you buy an equipment, ask for an external filter which will cut down your dust particles. Another thing is they are normally very reluctant to give you that filter. I don't know why, but even Sysmex was finally agreed. Yes, we have a filter and we'll sell it to you. The other thing is, don't throw that box away. Keep it, fold it, and keep it, just in case you have to pack that machine and send it to Nairobi for the service engineers or whoever to look at it. The original box should never be thrown away. Coming back to distilled water, please, please do not store your distilled water in a black container. That black plastic container is a recycled plastic, and it will leach into your deionized water. And your electrolytes, your calciums, your phosphorus will be outside the range. Do not use black containers. If your supplier is supplying you deionized water, ask him the TDS. Ask him not to supply you in a black 20-liter container. Ask him to supply you in a 5-liter translucent virgin container with a TDS of 000. This will this will help you tremendously, especially in your creatinines, your calciums, your magnesiums, your phosphorus. The TDS interferes everywhere. And the worst part of of not checking the TDS is the filters which are fitted in your sucking part of your, which are put in your distilled water to suck the distilled water. There are some ceramic filters which are fitted there. You will see they become brown. But if you use clear TDS zero water stored in a virgin container, you will not see that brown anymore, and your filter will last longer. And thank you very much. I've talked too much. Thank you for the opportunity.
Thank you, Taj. Thank you for your contribution. Thank you, everyone, for your contribution and for the questions that you've raised. Each one of them has been answered, and each one of them, each concern has been taken care of. Thank you, Chege, Martin Burungu. Thank you, Coril. Thank you, David, for your comments and accolades to Arthur. He has received them, and we are grateful that you're here. You contributed to this webinar this evening. I'd like to take this opportunity just to appreciate each and every one of you for creating time to be here. Thank you, Arthur, for preparing and presenting and articulating the whole life costing for smarter laboratory equipment procurement in Kenya, medical laboratories beyond the price tag. Thank you so much. And thank you, LMSK, for organizing this webinar and enabling us to be here, to be taught and to listen to the presenter today. And thank you for even Arthur for answering our questions and the concerns, and everyone that was able to contribute in one way or the other. I would want to take this opportunity to wish you a good evening, even as we close up this webinar today. We hope to see you on Monday for another insightful session from 3 to 4:30 Thank you so much. Have a great evening.